If you're watching this video, that means you either want to learn Git or just heard Git and want to know what it is. If so, then you've come to the right place. I'm Ali, and in this video we're going to answer some of the what and why questions about Git that you may have before learning it. Or as I said, maybe you just heard Git and want to know what it is. So in this video, we'll just talk about those questions, okay? Nothing technical. There's no Git commands or anything like that in this video. Now, what exactly is Git? Git is a software, so not a programming language or a concept, it's a software. A software that allows you to track the changes in your files and directories or your code and take snapshots of them at different points or special states in a database which we call a repository, or a repo for short. With that, we can travel through time. For example, we can go back to a specific version of a file. If you used Adobe Photoshop before, it works kind of like the history palette of Adobe Photoshop. As simple as that. But let's take a quick look at Git website and see what it tells us about itself. Okay, Git is a free and open source distributed version control system designed to handle everything from small to very large projects with speed and efficiency. Cool, Git is easy to learn. That's not exactly true, but it's not that hard and has a tiny footprint with lightning fast performance. It outclasses SCM tools like Subversion, Not Cool, CVS, Perforce, and ClearCase. I don't like trash talking, so anyway, with features like cheap local branching, convenient staging areas, and multiple workflows. Okay, it's free, which means you and I can just download it from here and install it in our computers, no payment required. It's open source, it means we can see the Git source or even collaborate on it. Look, it's all here. Okay, now what is distributed? And what is version control system? Let's first talk about version control system, or VCS for short. VCSs are made to track and view different versions of files over time. They allow us to move backward and forwards in history, or in other words, undo or redo the changes we've made in those files, and travel through time. You may not have used a version control tool like Git, but I'm sure you've used other version control systems before. You probably used file versioning when you're writing a document and name it version 1, then after a while when you added some changes to it, version 2, then version 3, final for the last version, then oops, we have more changes, so final version 1, final version 2, final version 3, final, and so on. Or I'm sure you've played at least one game before that had manual saving. Please don't say no. Games like Witcher, when you have to choose between dialogues and make important decisions, in that case, you need to save the game over and over manually, so if you accidentally killed an important character, you can go back and save his or her life. Or if you didn't play games and didn't use file versioning either, I'm sure you used Control-Z or Command-Z in Mac before. Yeah, that maybe is the simplest version control system in the world, but it has the main functionality of a VCS, right? What was the main functionality? Yep. Traveling through time. Not exactly traveling, but like undo things. Another primary purpose of VCSs is to manage the source code and its history. That's why they're also called source code management tools, or SCM for short. As you probably noticed from the Git website, the most common question for the people that just want to start programming is it necessary to learn Git? Because there are lots of things out there that I should learn, and Git seems like an optional thing. The answer is no. Git is not optional and you can't ignore it. Don't believe me? That's fine. Just look for the Git word in job descriptions. Then you believe me. But why almost every company out there are looking for a person who knows Git along with other technologies they want? The short answer is Without Git, you can't easily manage your code, especially if you have a big project like the Linux kernel or React with thousands of people working on them. Because you can't just create a new directory for this project and name it version 2 or final version. As you see, there are thousands of developers working on them. And what if the team wants the exact code that a developer recently made for a specific part of the project? That's hard to find, right? Especially in a project like React or Linux. How can they combine their code? It's just not possible that way, right? So people, mostly developers, need a tool to manage their code over time. So they can travel through time, so if something goes wrong, they can quickly go back to the point they want and start over or fix the problem. For that, they made VCSs. I'm not going to talk about VCS's history and their evolution, maybe in another video, but it almost took 2 decades to finally have something like Git. At first, VCSs can only track one file at a time, not the whole project, and they weren't cross-platform. Some of them weren't open source and even free, so you had to pay for them. And they weren't so easy to use, especially for teams to work as teams. So we have a genius guy, Linus Torvalds, who created the Linux kernel. This guy also created a VCS named Git that solved lots of problems that we had before. Actually, he created it for version controlling the Linux kernel because the ones was out there wasn't really good, so he created one. It was free and open source, as you saw before on his website. And it was cross-platform. You can install it on Mac, Linux, Windows, and even on Android. I'm not sure you can install it on iOS or not, but that's enough for most people. And one of the most important Git features is being distributed. So what is distributed? I'm going to answer that now. We have 2 types of version control systems, centralized and distributed. In centralized VCSs, we have a central server that clients communicate with. Imagine that you have a central server somewhere. It stores the main copy of your project. So everyone in the team needs to communicate with this central server as clients to work on the project. You as a client need to check out a copy of the project from that main copy. Then after a while you've added something to it, you need to commit those changes into the central server, and your colleagues to have those changes should update their copy of the project from that central server. Well, Git doesn't work that way. With Git, everyone has their own copy of the project. You can commit changes you made to your own repo completely offline, and whenever you want, you can push that change to a cloud repo or one of the company's servers, so everyone can have those changes as soon as they pull that change from that server to their repos. So there's no need to have all the changes, okay? Usually there's a repo for the project on GitHub or GitLab with the latest changes. We're gonna talk about them later, so don't worry. But that's optional when you're using Git. And if something happens to one of the copies, you can easily use another copy. On the other hand, in centralized systems, if something happens to the central copy, the whole team should wait for the server to be fixed. So that's a single point of failure. We don't have that in a distributed VCS because there's multiple copies of the repo. So we can do many operations offline in a distributed VCS, which means it can be faster and it has no single point of failure. Well, that's nice. And Git is the most popular distributed version control system out there. So now we know Git is very useful and even necessary for almost every developer. It helps you to manage your code, your project's history, travel to a certain point of your history, find and fix bugs, and it helps you to collaborate with other developers easily and merge your code with them. But when we should use Git? The short answer is always, even in small projects. But to be precise, it depends on the project. You may have a small project at the moment, but you have big plans for it. So it's good to manage your code from the first place. You can see that a lot of people out there are using Git, and lots of them are not actually developers, from big companies like Google, Facebook, Microsoft, to even scientists. Just come to this page and look for yourself. Even governments are using Git these days. Look. So Git and GitHub, which is a hosting service for Git repos, are very popular around the world. And when you need a clean versioning system or collaboration, Git is there for you. So Git and GitHub are not the same thing. Git is like a place to put your local repos on it, maybe for backup or to have a repo that always has the latest changes. This way, your team don't bother themselves to check who has the latest changes and get those changes from him or her. Okay, so how to use these Gits? There are various ways to use Git. When you download Git from here for your specific operating system, you can start using it from your terminal, or if you're using Windows, Git Bash. But you can also use GUI tools. We have a list of the most popular ones in here. So if you don't like the terminal environment, that's totally fine. You can use one of these tools. Just select your operating system and choose one of these. Okay, just one more thing. Git Workflow. I know, I said no technical things. But it's not technical. If you came here to know what Git is, then I think it's good to know a simple workflow. But if you don't like it, feel free to subscribe, like, then close the tab or app. And I hope to see you in the next video. But if you're still here, that means you're interested to know a simple version of Git Workflow. I don't know you ever noticed or not. I show you this page a couple of times, but what is with the logo? That is exactly what we're going to talk about. Look, that's kind of like the Git logo, isn't it? We start to develop a project, we take a snapshot of that project over time, we reach a state that we want to save, exactly like games when we think it's an important point that we want to save. So if we kill a character, we can go back and save him or her. So we take a snapshot, here's another point that we want to save, okay, another snapshot, then we take 2 more snapshots. But wait, oh, there is something wrong with this snapshot. No problem, we go back to the previous version. This is the tricky part. Up until now, we were doing this in a straight line of development. But now that we want to fix something, but we don't want to stop working on this straight line, we split the work. Want to continue on this line, the main line, maybe continue the main project development. On the other hand, we fix the problem we had with that snapshot in another isolated environment. Think of it as a new copy of the project in a new folder. This way, you don't need to be concerned about the upcoming changes on the straight line, especially if you're working as a team. And when we fix the problem, as you can see, we have snapshots in here too. Not that it is done, we can easily merge the code with the new changes in the main line, then we're good to go. Usually we will remove this temporary line after we merge the code, because to be honest, usually we don't work on this main line. We create another line, you start to work on that. Doesn't matter it's a feature or a bug. This way the main line stays clear. In VCSS, we call this branching. We have a main branch in some places like GitHub, a master branch, then other branches for bugs, features, tests, and other stuff. With a quick look at some repos on GitHub, you can see there are branches. For example, here we have Angular. You can see here at the moment it has 79 branches. If you click on it, you can see their names and some metadata about them. Okay, All of the workflow operations you saw until now were local operations. We don't need an internet connection for them. That was one of the pros of Git, right? But at some point, we may decide that we need to put it on the internet or share it with other developers, maybe on GitHub, that, as I said, is a Git remote repository hosting service, or GitLab, which is just like GitHub. Actually, there are lots of options out there, but these two are the most popular one. Choose one, put your repo on one of them, and then add your remote link to your local repo. Then you can push your changes to that repo. If it's on GitHub, then you push your changes on GitHub. If it's GitLab, your changes are going to be on GitLab. And other team members like Anna, in our case, can easily pull those changes in their local repo and merge your code with their code. Of course, if they want your changes. Easy peasy. Without Git, we couldn't do that. Okay? That's enough for now. Thanks for watching and see you in the next video.